Billions of miniature circuit breakers, or MCBs, are installed in residential and non-residential buildings or are used for industrial applications. In order to allow for typical appliance inrush currents, the MCB must remain stable during a minor short-term overload. However, if the overload persists, the MCB must open the circuit after a certain period of time. During a short circuit, an MCB must interrupt the current safely in order to minimize damage. MCB tripping characteristics show a thermal trigger for overloads and a magnetic trigger for short circuits. Different tripping characteristics for MCBs exist, such as D or C, with B being the type most commonly used. For instance, a B1 rating means that the MCB will instantaneously trip currents in between 3 to 5 times the nominal current, with the nominal current being 1 amp. Inside of an MCB, the path the current is taking across the closed contacts is visible, as are the tripping components. The higher the amplitude of the overcurrent, the faster an MCB must trip. This is achieved with a metallic element consisting of 2 different metals, which are heated up by the current flow. The 2 metals are expanding at different rates while they're heating up. An overcurrent that is present long enough will eventually activate the braking element. An MCB must open a circuit instantaneously when it encounters a short circuit at several times the nominal current. A solenoid and a piston are the elements used for instantaneous tripping. A short circuit creates an instant magnetic field that moves the piston and operates the breaker. Interrupting high fault currents can result in heavy arcing. Due to magnetic forces, the arc moves through a stack of metal plates where it is cooled, split, and finally extinguished at the next zero crossing. Despite its small size, an MCB has a rather sophisticated design consisting of 2 separate tripping mechanisms for overloads and short circuits. The quality of the materials used by the manufacturers differ widely. Therefore, some users would rather test their MCBs than simply rely on them. During testing, the MCB is disconnected from the circuit and connected to a test set. The test set generates different currents in order to simulate load conditions and fault currents. The short circuit tripping element is tested first. The overload tripping element is tested next. A stability test with nominal current completes the test for this MCB. This one is working fine. And now, on to the next one.